You know the Awesome project. Awesome is a curated list of resources on a specific topic, typically hosted as a GitHub repository. These lists contain carefully selected links to libraries, tools, frameworks, tutorials, and other resources. For instance, there is a comprehensive list for Python that covers everything from web frameworks to machine learning libraries, and there is one for .NET that catalogs C# and .NET resources. There is even a meta list of lists, an awesome list that references other awesome lists, but ironically, not every awesome list makes it to this collection. If you're looking for a specific awesome list, your best bet is to just Google it or Bing it if you're feeling adventurous. But there are a few significant issues with traditional awesome lists. First, the workflow to add a new link is unnecessarily complicated. I mean, seriously, take a look at this. You need to fork the repository, clone it locally, find the right place in a README file, and add your entry with proper Markdown formatting, ensure alphabetical ordering, add specific tags, commit your changes, push to your fork, and then open a pull request. All of this just to add a single link. And that's not even the end of it. Your PR then sits in a queue waiting to be reviewed by a maintainer who may or may not be active. It could be merged immediately, or it might take weeks, or it might get rejected for minor formatting issues. Second, some awesome lists simply get abandoned and forgotten over time. Maintainers lose interest, move on to another project, or just burn out. When this happens, all the community effort and valuable contributions essentially vanish into the void. Sure, you can fork an abandoned repository and try to revive it, but forking has real consequences. You lose this star count and community recognition, existing contributors might not find your work, and you're now competing with the original repository in search results. It fragments the community. So I've decided to completely reimagine how awesome lists should work. And naturally, I've used C# for this. I've created a new awesome list system that will basically outlive me. It's designed to be self-sustaining and requires minimal maintenance. I don't need to be actively involved in day-to-day operation at all. Let me walk you through how it works from the user's perspective. First, instead of going through that complicated pull request dance, you simply click Create New Issue, which presents you with a structured form. No more free-form text where you need to worry about specific formatting, correct punctuation, or pedantic white spaces. No more getting your contribution rejected because you forgot a comma or used the wrong indentation. The form has clearly labeled fields. You enter the link name, select a category from a drop-down, optionally choose a subcategory, paste the actual link URL, and write a brief one-line description. Then you just press Create to submit the issue. That's it. No Git knowledge required, no Markdown syntax to memorize, no alphabetical ordering to figure out. Once submitted, the issue sits in the queue until one of two approval conditions is met. Either I, as the BDFL, that's Benevolent Dictator for Life, click the thumbs up reaction on the issue, or 5 different community members give it a thumbs up. I probably should have set the threshold to 10 like, because then I could legitimately call myself a 10x developer, right? When either approval condition is satisfied, the magic happens automatically. The issue is converted into a line in a CSV file that acts as the data source, and the README file gets completely rebuilt from scratch. Now, before this automation kicks in, I will have the opportunity to review the issue manually if I want to catch any spam or inappropriate content. And of course, other users can leave comments on the issue to discuss whether a link is actually valuable or if there are concerns about it. Let me explain the technical implementation. To replace the standard GitHub issue dialog with a custom form, you create something called a GitHub issue template using YAML configuration files. These templates are incredibly powerful. They let you define exactly how the form should appear, which fields users need to fill out, the field types like text inputs or dropdowns, whether fields are required or optional, and even validation rules. The configuration file can also disable blank, non-templated issue creation entirely, which means users can't bypass your structured form and submit random free-form issues. This keeps everything consistent and machine readable. The heart of the automation is a GitHub Actions workflow that monitors several trigger events. It runs whenever an issue is created, edited, labeled, or when someone comments on an issue. It also runs on a scheduled basis every hour to catch anything that might have slipped through, and it triggers on every push to the master branch. The workflow itself is beautifully simple. It spins up a clean environment, installs the .NET SDK, executes the single file C# application called x.cs, and I should probably have called it 10x.cs, and if that application makes any changes to the repository files, it automatically commits those changes back to Git and pushes them. No manual intervention needed. The .NET application itself performs two distinct operations. First, it processes open issues. It makes an API call to GitHub to fetch all open issues, then intelligently filters them by skipping pull requests and issues that don't have the proper labels from our template. For each remaining issue, it evaluates whether the approval conditions have been met, either my thumbs up or 5 community thumbs ups. If an issue qualifies for approval, the application posts a comment back on the original issue, thanking the contributor, automatically closes the issue to keep things tidy, and most importantly, appends a new line to the CSV file that serves as our database. This CSV file is the source of truth for all approved links. Second, it rebuilds the entire README file from scratch. This is where Link really shines. The application reads the CSV file, performs proper string trimming to clean up any whitespace issues, applies correct capitalization rules where needed, like ensuring category names are title cased, sorts both category names and the links within each category alphabetically for easy navigation, generates clean markdown formatting, and writes the final results back to disk. Every time this runs, you get a perfectly formatted, consistently structured README file. So essentially, the system automates me right out of the equation. It gives users a friction-free way to contribute valuable links while simultaneously adding a layer of community-driven quality control through the voting mechanism. The best part, even if I completely disappear tomorrow, the system keeps running. The community can continue to add and approve links without any maintainer involvement. It's self-sustaining by design. This approach solves both major problems with traditional awesome lists. It eliminates the complicated contribution workflow that discourages participation, and it ensures the list can never truly be abandoned because it doesn't depend on a single maintainer's continued interest or availability. I hope you find this idea exciting as I do. If you want to check out the actual implementation or contribute a link yourself, don't forget to visit the repository. The link is in the description below. And of course, if you enjoyed this video and want to see more content about creative automation and C# projects, don't forget to press like and subscribe. See you later.